Week 1 is complete. Let's close that up. Week 2, first bad version. You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails to quality check. Since each version is developed based on the previous version, all versions after a bad version are also bad. Suppose you have n versions, 1, 2 to n. I'm going to find out which is the first bad one. You're given an API is bad version, which returns whether the version is bad. Implement a function to find the first bad version. The API is bad version is defined for you. To call it, use self.isBadVersion. All right, so we're going to have to implement it ourselves so that we can do our tests. Input is 5, bad is 4, the output should be 4. How do we want to do this? All right, so we have 278, which comes right in here. Like that. That's interesting. Now it says no code actions available. But if I do it right away, say I moved. I moved the cursor and then it said no code actions available. Okay, so let's just copy this whole thing and paste it in here. We are going to have to write our own is bad. Oh, I can't do it that way. Is bad version. It has to be that name. Self and I32, and it's going to return a bool. Yeah, so this API is slightly off. There should be a self parameter right here. Okay, so let's have it return 0 for now. Let's have this return false for now. And then we'll write our test. Example 1. We should say assert equal solution. Oh, this needs a self, so we're going to need to create a solution. Let first bad version is equal to solution new, and we'll give it the bad version of 4. Okay, so that helps us define our struct here. Pub struct solution bad version is an I32, and then we can create a new which takes in a bad version I32, which returns a self, which creates a self of bad version, like that, and then we're going to say assert equal FBV. That's hard to type. First bad version of 5 versions is 4. All right, and that should fail. Yep. Okay, so we were expecting 4 and we got 0. Very good. So now how do we write this? We could just return bad version here. That won't work. So what we need to do is, first of all, we can write is bad version now. Now that we have the code, we can say self.badverge is less than n. Right? If the bad version is 4 and n is 4, that's not less than n, so that means it's going to return true, saying it's a bad version. If n is 2, then we don't have a bad version. If n is 100, then we do have a bad version because n is greater than bad version. So that's how that logic works. All right. So the first thing we can do is let's take a look at, let's figure out like the good versus the bad. So we know the first good version is going to be 1. We start at 1, right? And the bad version, out of n, we know n might be a bad one. Like that. And now what we want to do is narrow down which one it is. So we're going to loop. This is almost like a binary chop, except not quite. Because we're still going to calculate the midpoint. Good plus bad over 2. If self is bad version mid, then we're going to set the max to the mid point. Not the max. The bad is the I was thinking binary tree again. So that's the max. The bad one is the max. Else, the good version is the midpoint. Right? Because we've calculated that it's a bad version or it's a good version. Then we want to say, because we know we're going to go dot, version. These are all good. It'll be good, and then it'll switch to bad. So if the good plus 1 is equal to bad, then we know we found the first bad version, which is bad. Which is stored in bad. And that'll loop forever. That should do it. Yeah. I think that covers all the bases. Oh, right. For some reason, they've decided to use a camel case for this, so we just allow it. And this is failing. Okay, so what did I do wrong? If left is 5, yeah, it should be returning 4, and it's returning 5. So we can just print these out as we're finding them. Println checking mid. And see what it says. It's checking 3. So 3 is going to be not... I can just print it out here. Self is bad version mid. Okay, so that's our first error right there. Checking 4, it's saying false for bad version. And it should be saying true for bad version. So this should be equal. Yeah, okay. Bug fixed. All right, I think that's it. And this code is already supplied to us. Should we do the next example? Let's just do this example here. ex2 let fbv equals solution new 1 assert equal fbv first bad version of 1 should be equal to 1. And we're in an infinite loop. Okay. I guess we could hard code that case with only one version. We just keep, there's no good version to look at. So if the first version is the bad version, we just got to return that right away. So if self is bad version 1, return 1. All right, I'll hard code that sucker. And that passes. Dangley says, isn't self bad version the first bad version? It is, Dagley, but we actually have to write an algorithm to find it because we're not given that here. In this, all we have is the API to query what the whether or not n is the value we pass in is the first bad version. But yeah, otherwise this would just be return bad version. All right, so yeah, let's submit this as our solution to this problem here. Paste. Let's run this. Okay, that was accepted. Oh. Oh. Interesting. I bet just this overflows. I bet you this overflows. So, okay, I'm going to cheat. I'm going to cheat in the best possible way. Actually, I should add this as a test. Right? Test. Let FBV equal to. Actually, I should have tested it this way first before I made these edits. Yes. EX3 or overflow case. So this is let FBV equals solution new, and the first bad version is going to be, I assume, the lower number. And then we just want to say, there we go, FBV dot first bad version of the upper number. Why wouldn't it let me just is equal to the lower number? And this should overflow. This should show the overflow. It panicked, attempt to add with overflow. Yeah. So, like I said, I'm going to cheat my way to a fix here. As I32, as I32. There we go. And now we'll just insert this as my solution. Paste. Submit. Oh, there we go. Okay, it's accepted. 1 millisecond, 2.1 megabytes. It's kind of cheating. It would be good. It would probably be better to figure this out, a way around the overflow condition without doing that, but whatever. It works. I'm going to take it. Get status. Get add source. Get commit. Problem 278. First bad version. There we go. Beautiful. Should we do another one?